So we know that we have studied the Archimedes principle and as well as the important property of buoyancy. So let us see first, we'll make the quick recap of Archimedes principle. So Archimedes principle, we're having it through two definitions. What is the Archimedes principle will say is the upthrust. What is another name of upthrust, everybody? Upthrust also we can call it as a what?
Point force.
Buoyancy force. So the buoyancy force exerted by the liquid on which object, guys? Exerted by the liquid on which object? Either partially immersed object or it is
Completely immersed.
completely immersed object. So when the object is immersed partially or completely, then the body will experience the buoyancy force. This buoyancy force depends. That is what upthrust is equals to weight of the liquid displaced by the immersed portion of the body. So weight of the liquid displaced. That is what we used to call it as a upthrust. So that upthrust is equals to, also we can say another one. What is that? So when we keep the object, suppose I kept some object in the air. So in air, it is having a different weight. So weight of the object in air is definitely greater than weight of the object in the what? Liquid or fluid. Am I right or wrong, everybody? Please respond. So same liquid, same object is kept in the any liquid. Weight of the object in air is always greater than weight of the liquid in the weight of the object in the liquid. So that is what we used to call it as. So how there will be some change in weight. So when you take the object from air into the water, air into the any liquid, definitely there will be a loss of weight of the object. That is only we used to call it as a upthrust. That is what. So how much it is loss? Loss in the weight of the body. So that is what we used to call it as a upthrust. That is only we can say Archimedes principle. So this loss in weight, how we can calculate, guys? We all know. I have taught you the formula here only there. What is that? Weight of the body in air minus weight of the body in where, guys? Weight of the body in where? In a given liquid when it is immersed partially or when it is immersed
Completely.
Mr. Kishore. Lingesh, when it is immersed completely. So that is what we used to call it as we used to say Archimedes principle. So now we have calculated the important property of buoyancy. So what is the buoyancy formula? Buoyant force formula. Everybody? Yes, please. Buoyant force formula. What is that? All of you. Which is equals to weight of the liquid displaced. So weight of the liquid displaced formula is what? Everybody? Mass weight of the liquid. So weight means what? Mass of the liquid displaced into G. So we all know that from the density formula, density is equals to mass by volume. Mass is equals to rho into density into volume. That is what V means what? Volume of the liquid displaced. So what is the buoyancy force formula? Density D or rho into V1 into G. So what is the V1, guys? Everybody. V1 volume of the object, not volume of everybody. Volume of displaced liquid. Clear, everybody? Volume of displaced liquid into G. So that is only ways to call it as a buoyancy force formula. So buoyancy force is equals to rho V1G. V1 means volume of the displaced liquid. So rho V1G, or we can take it as a dV1G. So this is the formula for buoyancy force. Last class I have taught you this. Am I right, everybody? Clear, all of you? Please respond, everyone. Understand, Amma? So now let us take today's class. We are going to see that is what floating and sinking. So as I said you. So let us see, all of you. If I take two objects, let me take two beakers of water. This is the beaker 1. And I have taken another beaker of water. Okay. So that is what I will take it as a fully, both are filled with the water. Both are filled with the what? Everybody? Water only. So now if I have noticed it, I will take two materials. One is a piece of cork, material 1, and I will take another one is a piece of iron, So now I will put a piece of cork in the beaker 1 and I will put a piece of iron in the beaker 2. Now tell me which one will sink and which one will float. Anybody? All of you? Yes, please. A piece of cork and piece of iron. So which one will sink and which one will float? Or you can take it as an iron nail. You can take it. Okay. So now you tell me. So which one will sink and which one will float, guys? What you are expecting?
Iron will sink, sir.
Yes,
Cork will.
others. So iron will sink and piece of cork will float. So let me take a piece of cork. So we all knows that piece of cork is floating above the surface because it is understanding its density is less. So it will float. Now, why it is, I will teach you that. So now another iron nail. So iron nail will come and will settle at the bottom of the container. Will you all agree with me, everybody? Yes, please respond, guys. That is what it is. Okay. So now you can see, but the same boat, if I have taken, so ship or boat, huge amount of iron is used, huge amount of metals is used. But if the ship is entering into the water, is the ship will sink or float? Everybody?
Float,
Is
sir. That because there is a hollow surface at the bottom of the
yes,
ship, sir.
not
Which
only
is
bottom, Mari, whole density, not the bottom. Okay. So if I've taken a ship, everybody listen, all of you. So ship will be having actually hundreds of you can take hundreds of kgs of metal and everything, but still the ship will float. So because the reason is that is what the floating and sinking concept. So let us discuss what it is. Okay. So what exactly floating and sinking means? So be very careful. Now, if I take any kind of object, if it is floating or sinking, doesn't matter. Always remember, if a liquid is the object is immersed partially or completely, or it is a floating, whatever it is, always the body will experiences two forces. When the object is in liquid, any kind of object, so definitely there is a force which is always exerting downward direction. That is what we used to call it as. Anybody can tell? What is the force which is acting downward direction? Everyone? Yes, please. Always
that
downward direction. Yes, please.
weight. Weight.
Weight.
Gravitational force.
No, gravity not. Yes, weight. So weight is equals to m into g. That is what. Next. Always there is a force which is acting upward direction from the bottom surface. From the bottom surface, there is a
Buoyant force.
yes. That is what we used to call it as a FB, buoyant force, or you can take it as a F, or we can take it as a upthrust. Whatever you are convenient, you can take it. Are you clear, everybody? All of you? So keep it in mind.
So even weight can we call it as thrust?
No, weight you cannot call it as a thrust.
No,
Thrust,
sir.
yeah, you
Thrust.
can, Mari, but both are thrust, upthrust not required. You use always a weight. That is important. Clear? Yes. So keep it in mind always. Buoyant force by the liquid. This is by the liquid. So which is always exert in what direction? Everybody? Always exert in what direction? Upward direction. Buoyancy force always will exert in upward direction. Understanding? Either object will sink or float above the surface or inside the surface. Doesn't matter. And weight of the object. It is actually weight of liquid, not. What is that, everybody? Weight of the object. Which object? Anyone? Which object? Immersed object. So weight of the immersed object is always, we will take it as a downwards or upwards. See here, it is always taken as a what, guys? All of you?
Downwards.
Okay, that is what. So weight is represented with the W, force is represented with the FB, buoyant force. Now, when the object will sink, when the object will float, when the object will sink, float below the surface. Now, all of you observe. I will draw you three different cases. Three different cases will teach you three different things. You should remember that. Now, I'm having a liquid. Okay, so same. I'm having another liquid, like you can take water or whatever it is. Okay. Next, I'm having another liquid. That is what? Same. All three containers is having a same substance. Now, I dropped some substance here. Directly, they went and settled at the bottom. Understanding? Now also, there is a force which is acting downward direction. What is that, everybody? Yes, please respond. Weight. Clear?
Wait.
And there is a force which is acting upward direction from the center or from the bottom surface. From the bottom surface, there is a force. What is the force? We used to call it as a, everybody.
Buoyant force.
Buoyancy force. Now, here the object is floating above the surface. The object is floating above the surface. Now also the weight of the object is acting what direction? Everybody. Weight of the
Downward.
object is acting in what direction? All of you? Downward direction. Are you clear? Now also the buoyancy force is acting what direction? All of you?
Upwards.
What direction?
That is what. Now, object is floating exactly below the surface. Below the surface. Now also, with the force which is acting downward direction. What is that, everybody? Weight. Now also there is a force which is acting upward direction. What is that, everyone? Speak loudly, guys. FB, buoyancy force. Clear, everybody? So these three things you remember. Now you can see. This is first one. First one is what, everybody? Sinking or floating up? Completely sink. Do you understand, everybody? This is sink. And this is actually float. And float above the surface. This is actually float above the surface. This one is what, guys? Floating.
Below the surface.
Floating below the surface. So that is what? Below the surface. So how you can say either it is sink or floating below the surface or above the surface? It is purely based upon weight and buoyancy force. So check it, everybody. Whenever, see, now you tell me, now the object is sink. So to whom you are thinking greater? Buoyancy force or weight of the object? Everybody?
Weight of the
Weight of the object. Very good. So weight of the object is greater than buoyancy force. So object will sink or float. Everyone, Alfin? Yes, please. The object will sink in the liquid when weight of the object is greater than buoyancy force. Anybody having any problem, you can ask me. Are you clear? Darshan, Arasini, late. Okay. So now you can check it. Next, floating. It is floating above the surface. Then whom you are thinking more? Weight of the object or a buoyancy force? Anybody? Yes, please. It is almost came up. It is floating. So then what will happen? Agalya, who is greater? Everybody.
buoyancy force.
Force is greater than weight of the object. That is the condition which you have to remember. Weight of the object is less than the buoyancy force. That is what you have to remember. Okay, guys? Everybody? Clear? Please respond. Next.
Yes, sir.
It is floating just below the surface. It is floating just below the surface, neither up nor down. So can you tell me what is that? It is along with the liquid, it is floating. Along with the liquid, it is floating, guys. So what will happen? Everybody? Yes, please. Along with the liquid, it is floating. So what you can say is, everyone? Niveda, Kishore?
Equal.
Yes, that is what. So weight of the liquid, sorry, weight of the object is equals to buoyancy force. Then in this case, neither up or nor down, it will just float above the, just below the surface, it will floating. That's all you have to remember. Okay, guys? Everybody? Yes? Please respond.
Yes, sir.
That is one. So please make sure this is the concept, call it as a floating and sinking. Now we are going to write the principle of flotation. So what is the principle of flotation? That is all we'll discuss now. First, we finish this. Anybody having any doubt in this, you can ask me so that I'll proceed. Clear, everyone? Yes.
Yes, sir.
Understand, Princey? Mr. Mukesh, Niroshi?
Yes, sir.
Okay. So these are the three cases you have to remember. Okay, everyone? So please write it, everyone. So weight of the object is greater than the buoyancy force. Object will sink or float. Everybody? Object will sink. Next, buoyancy force is more than the weight of the object. Then object will float above the surface. Next, if the buoyancy force, okay, if the I just revised the lecture, nothing is there. If the buoyancy force of a liquid is equals to the weight of the liquid, weight of the object, then the object still it will float, but will where, guys? Everybody? Below the surface. Understanding, all of you? Along with the liquid, it will float. That is what it is. So it will just below the surface of the liquid. It will float just below the liquid surface. That is what you have to remember it. I hope you all understand. Anybody having any doubt, you can ask me. Are you clear, everybody? Please respond. So greater than weight of the object. Weight of the object is always exerting downward direction. That is what we can say mg. Weight is equals to mg. Then if it is immersed, definitely it will experience a upward force. So what is upward force? We used to call it as a, yes please, buoyancy.
Upthrust.
Understanding? Upthrust, or we can say buoyancy force. Now, one most important concept I'm going to introduce you now. After this only we'll study principle of flotation. So just have a glance, very careful. If you have any small doubt also, you can ask me immediately. Okay. So let us seize that now. If I take for example, I have taken a two beakers. One is water, H2O. Another one is mercury. So mercury means what, guys? Everybody, Hg. Am I right or wrong? All of you? Please respond. Understand,
Yes, sir.
Dada? Now, if I put a iron nail, if I put a iron ball in the water, so what you are observing? What is your observation? General. Anybody? If I put a iron nail in water, what is what will happen to the iron nail? So iron nail will come and will settle
Sink.
at the bottom. Am I right or wrong? Two iron nails of same I have taken. Everybody clear? Yes, please. Now, if I put the same iron nail on the mercury, do you think that it will float or sink, or it will float above the surface, or it is float below the surface? Anybody? Yes, please. All of you?
Float below the surface.
No. It will never even sink. It will just float above the surface. Because I will say, listen, density of iron is 7.8 meter per kilogram per cubic meter. I'm saying wrong. Gram per cubic centimeter. What is that, everybody? All of you? Yeah, please mute
Gram
yourself.
per
Some will try.
cubic centimeter.
Yeah. So
Gram per cubic
yeah,
centimeter.
density of iron is 7.8 gram per cubic centimeter, or we can say 7,800 gram per cubic centimeter. Ellame understood? Everybody? Now, if I take density of mercury is 13,600 kilogram per cubic meter, or we can say 1.36 gram per cubic centimeter. Centimeter. So now if I take water, density of water. So now you can say, all of you. So what will happen? Density of water, 1 gram per cubic centimeter. And if it is kilogram, how many grams? 1 gram is equals to 1000 kilogram per cubic meter. So this is what is the things you have to remember. Now, iron and water, if I compare. So what will happen, everybody? Everyone speak loudly. Iron density is greater than water. So it will sink or float off, everybody. Iron density is
Sink.
greater than water, so that it will sink. Now, all of you observe mercury. Yes, please. What is the mercury density? Not
Sir,
1.36.
so one doubt, sir.
Yes, Mari. This is 13.6. Please note it, everybody.
The unit will be
13.
changed, sir. That's
Ah,
kg per meter cubic
Ah.
meters.
where, Mari?
7,800
Ah,
kg
yeah,
cubic
yes,
meter.
Mari. Yes, Mari. Yes, Mari. Units are wrong. Kilogram per cubic meter. Okay, wa?
Yes, sir.
Yeah, that is what. So iron density is greater than the water, so it will sink. Now, if I take mercury, density of mercury is actually a liquid. So that what will happen, everybody? Density of a mercury is greater than density of iron. So that what will happen, everybody? Obviously, the iron nail will float or sink. Everyone.
Float.
Float.
It will float. Okay, that is what. So same object may be sink in the some other liquid. Same object may be float in the some other liquid. That is the most important point which I want to say. So please note it. The same object may be understanding float in some other liquid. The similar object may be sink in the some another liquid. That is what you have to remember. So always you have to be very careful regarding this. Clear, everybody? So density means mass by volume. So be very careful. Densities will gives us the information exactly, like, okay, either the object is going to sink or the object is going to float. So we start now. Everybody clear? I hope you all understand this question concept. Yes, Mr. Darshan, understand? Shivani?
Yes, sir.
Yeah. Now you can see, I will teach you. Let me take one object. So I have taken a water. So what is the water density? Anybody can tell? Density of water. Yes, please. 1 gram per cubic centimeter. Let it be. This is. Now, I put some object. In that, I noticed that 1/2 object, that is what 1/2 of the object is inside and 1/2 is above the surface. Do you understand, all of you? Please respond, everyone. So when I
Yes,
put
sir.
it in the water, now same object I have taken into, let me take now for example glycerin. What is the substance I have taken, everybody?
Glycerin.
Yeah, glycerin. Now, all of you observe here. Object is remains same. I am keeping object is remains what? Object is remains
Same.
what? Same. Now listen, everyone. So, if you have taken 1 minute. Yeah. So if I have taken a glycerin density is 1.26 gram per cubic centimeter. Now, the object which is immersed, just I am taking the different density of the object is equals to 0.3 gram per cubic centimeter. Now, you can see here what is the immersed portion, everybody? What is the immersed portion? All of you, half. Now, same object will come into here. Here I noticed it just only 1/4 of the object is floating. 1/4 of the object is floating. Okay. Now, here also density of substance is how much? Same substance. Same substance. What is the density of substance? Anybody? Yes, please. All of you. Density of a substance is remains same. 0.3 gram per. Yes, Mr. Pranav. 0.3 gram per cubic centimeter. Understand?
Yes, sir.
Yes, Mari, Lingesh,
Yes, sir.
Sanjay. Yes. So now all of you observe very carefully. So from here it will be taking turn now. So even because it is most important point. So can you tell me what is the density difference between these two? Difference in density. Yes, please. Difference in densities. Yes, please speak, everyone. Density of water minus density of object, which is equals to 1 minus 0.3, which is equals how much, Ra? All of you. 0.7 gram per cubic centimeter. This is the density between the Ma 0.3 amma. 1 minus 0.3, how much? 0.7 only, guys.
Yes, sir.
Yes. Next. Now, density of substances remains same here. Now you see the difference here. 1.26 into 0.3. What is the difference you notice? Anybody? How much is the value? How much is the value? Yes, please respond. 0.25, sorry, 0.26 minus 0.3 gram per cubic centimeter. Do the subtraction and tell me fastly, everybody. 1.26 minus 0.3, make it quick. 1.26 minus 0.3. How much, Ra? All of you? 0.96 centimeter per second square. Okay. So why I am saying you this here, keep in mind, same object when it is kept in a water, immersed portion is different. Same object is kept in a, understanding, glycerin, the only 1/4 of the object is immersed. So both the cases, if you notice it, everybody, both the cases sinking or floating are. Both the cases it is sinking or floating, everyone. Yes, please. Both the cases, what is that, guys? Please respond. Both the cases, it is sinking or floating. Everyone, it is floating.
Floating.
But here it is only half of the portion is immersed in the liquid. But here only 1/4 of the liquid is immersed. Now, that is the point I am making a extremely important point. That is what? Greater the density difference, higher will be the buoyancy force. That is what you have to remember. Are you clear what I'm saying? Lingesh, Sanjay, Sam, the differences. So now tell me these two, who is experiencing more buoyancy force? More buoyant force, which is sink 1/2 of its volume, or which is sinks only just 1/4 of the volume. Anybody? Yes, please.
1/4.
1/4, because here the density difference is higher. So greater the density difference, higher will be the what? Everybody, higher will be the buoyancy force. That is what you have to remember it. Anybody having any doubt, you can ask me. Density difference. Puri mama, everyone. So please make sure this point is a very, very important point. Okay. So greater the density difference between the liquid and the immersed object, higher will be the buoyancy force. That is what you have to remember. So compared to water, glycerin, who is exerting the more buoyancy force? Either water or glycerin? I want to know. Everybody? Who is exerting more buoyancy force? Glycerin or water? Everybody?
Glycerin.
Okay, that is what. Understand? Agalya, Alfin, Shivani, Harasini, no response at all. Danishka also. So clear, everybody? So greater the difference between the densities of immersed object and liquid, then higher will be the buoyancy force. Write that point, everyone, and learn. It's very, very important. Okay. Any doubt, Mr. Gokul? Hasini Sudhaka? Please do it. Purima, ellame understood?
Yes, sir.
Yes. Do it, do it. Very, very important.
The greater will be the difference of density.
Yeah. Write the statement. If greater will be the density difference, not density difference. If greater will be the density difference, greater will be the density difference between the liquid and the immersed object. immersed object, greater will be the density of the object and immersed liquid. Understand everyone? Then higher will be the buoyancy force. That is what you have to remember it. Any problem for anybody? You can ask me. Are you clear, everyone? Yes, please.
Yes, sir.
Yes. So now, this is what is the main important point which you have to remember. Now, let us study 3 different cases. We have at least one case. Now, principle of flotation. So what is this principle of flotation? Let us discuss now. So all of you keep reading. Principle of flotation. Principle of flotation. Make sure you all will understand very clearly, and then only you can proceed. Okay. So let's start now. Everybody, Agalya, that is it. So let us take now. If I take a container, all of you remember, some object is kept inside it. Some object is kept inside it. So now keep in mind, I am assuming density of the liquid is D or rho. So whatever it is.
Sir,
Yeah.
is it rotation or?
No, Mari, it is a disc. It is a container, Mari. Container, and it
No,
is
sir. Flotation or rotation, sir?
flotation. 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 Principle of flotation. Clear? Now, imagine there is an object which is kept inside the liquid, immersed object. Now, I am taking, listen, all of you. Density of liquid is actually, you can take it as a D, okay, or rho, your choice. And as already density of liquid we have used it. Now you can see, we can say is the buoyant force or upthrust. Now how much it is exerting in this object, we are going to find it now. The formula is the density of a substance, immersed substance, density of a substance. Let us take the sigma. What is the rule, everybody? Name of it, everybody? And volume of the object is V. What is the volume of the object? Please respond. V. Capital V. Volume of the object is capital V. Then buoyancy force or upthrust, or you can take the force which is exerted by the liquid. So which is upthrust is equals to, formula is weight of the liquid displaced. That is only we can say weight of the liquid displaced. Write it, everybody. Weight of the liquid displaced. That is equals to what, everybody? All of you, which is equals to upthrust. Now, so we all knows it. All of you observe very carefully. Weight of the liquid displaced is equals to, what will get it? M into G. Now M means what? All of you speak. M means what? Everybody, we all knows, guys, density is equals to what? Mass by volume. Mass is equals to what? Density by, yes please, volume. Clear, everybody?
Density into
Yes,
volume.
yes, ma'am. Density into volume. Very good. Density into volume. So that we'll get upthrust is equals to density into volume of the what? Object or liquid. Here see, capital V I assumed. What is that? Volume of the,
Sir, one doubt, sir.
yes.
In total, what are we trying to find, sir?
We are trying to find the upthrust.
Yes, sir.
Clear? So weight of volume of the object into, now you can see, all of you, G. Acceleration due to gravity. So density of liquid is rho or D. You can take D. Volume of the liquid displaced. What is the volume of the liquid displaced? Let me take V1. What is the volume of the liquid displaced? Sorry, here it is volume of the liquid displaced. How much liquid I can take? Can I take it as a V1? If this object will go out, it will come V1 volume. Is it okay? Wow. Yes, please respond. So
The liquid pressure is equal to rho GH, sir.
So density into V into, let me, V1 into G, because volume of the liquid, I am assuming as a what? V1. Volume of the immersed object is V, capital V. So now if you notice it, according to this, all of you remember, next, if I write another formula, so weight or upthrust is equals to, what is that? Mass into acceleration due to gravity. Mass is equals to again what? Density of a substance, and you can notice it. Now here, density of a substance, we have taken, what is the symbol? Sigma. Sigma is equals to mass by volume. So mass is equals to, it's not 6 ra, sigma. Sigma into volume. So your choice it is. So what will happen? I'll replace in place of mass, sigma into, okay, sigma into, what is that, guys? Sigma into volume, correct? Sorry, volume of the object. Sigma into volume of the object. What is the volume of the object? V into G. So this is the formula for weight of the object, and this is the formula for weight of the liquid displaced. Sigma is the density of a substance, because rho you cannot take. I have taken totally 4, guys. Listen. Density of a substance is sigma, volume of a substance is V, density of a liquid is D, and volume of the displaced is V1. That's all, everyone. Purima, please respond, all of you. Clear?
Yes, sir.
Yeah, but actually what we studied that, what is upthrust? Anybody can tell me what is upthrust formula? Make it quick. Upthrust formula. Upthrust is equals to what, guys? 2 formulas are there. I taught you. Everyone. What is that? Weight of the liquid displaced or loss in the weight of the body. Am I right or wrong, everybody? Yes, please. So both are,
Yes, sir.
remember, both are actually calculating the upthrust. This is the weight of the object. So we all knows that if I take any kind of object, so weight is acting downwards, buoyancy is acting upwards. So buoyancy is equals to, what is the formula? Upthrust, everybody. D into
Density.
V1 into G. What is V1, Shivani? Agalya, what is V1? Volume of the liquid displaced. Volume of the liquid displaced. D means what? Density of the liquid. G means acceleration due to gravity. Then what about the weight? Weight is equals to what, everybody? Weight is equals to what? Sigma into V into G. What is sigma, everybody? Sigma means what? Yes, please.
Density.
Density of a substance. This is regarding substance. Please note it. Immersed substance. And this is about liquid, where the object is immersed. So that is what you have to remember. Now, with the help of these formulas, density, we will solve in the next class. How the